Dear students, in this presentation we will take up the last component, that is the refrigerator. Directly go to the statement. The question is, the refrigerator shown in the figure below uses R134A as the working fluid. The mass flow rate through each component is 0.1 kg per second and the power input to the compressor is 5 kilowatt. The following data are known. Using the state notation of the figure, determine the following. That is the quality at the evaporator inlet, which is nothing but evaporator is here, so its inlet, that is X4. So I have mentioned here the quality at that X4. The rate of heat transfer to the evaporator, how much heat the evaporator is going to absorb. So that you have to evaluate. And then third one, the rate of heat transfer from the compressor. So from the compressor, how much heat is being lost. This you have to evaluate. Now take up this as a homework and calculate all these parameters in the same way as we have done for the other numericals. So here I will be just guiding you through, whereas you will be attempting this particular numerical for R134A in the same manner as we have done it for the other numerical. So this is the given data. P1 and T1 means here at this state the pressure and temperature of R134A is 100 kilopascal and minus 20 degree Celsius. P2, T2, that means after it comes out of the compressor, its state is pressure 800 kilopascal and temperature 50 degree Celsius. T3 and X3, that is after condensation process is over, the temperature of R134A is 30 degree Celsius and X3 dryness fraction or quality is 0. That means here it is saturated liquid. X0 means saturated liquid. And then T4 is minus 25 degree Celsius. After it passes through an expansion valve or throttle valve or capillary tube, the state here temperature is minus 25 degrees Celsius. So this is about the figure. Now you are supposed to find out all this X4, Q dot evaporator and Q dot compressor. Now you decide which equation is to be used of the two, the first law forms, either the total form or on mass flow rate basis. Now here I have given you the hint here that for a control volume enclosing the throttle, refer to the sketch, the first law gives for throttling it is isenthalpic process. Remember, the enthalpies at the inlet and exit are equal and rest all terms they vanish. Hence I have taken H4 is equal to H3, and at 3 at the entry of the throttle the temperature is 30 degrees Celsius and the dryness fraction is 0, so it is saturated liquid. So find the enthalpy, that is H3 for R134A from the table, and you can note down that it is 241.8. Equate this to find the value of X4, that is the dryness fraction at the exit of the throttle valve. So it is given by HF plus X HFG 4. So where HF4 is to be calculated at a temperature of minus 25 degree Celsius for R134A table. Similarly HF4 at minus 25 degree Celsius, so that the unknown term X4 can be calculated. So you should get X4 as 0.345, that is 34.5% dry. Next is a control volume enclosing the evaporator, where we are supposed to find out what is the amount of heat absorbed. Remember, here it is not heat rejected, it is heat absorbed, so it is positive, which is given by the equation mH1 minus H4. Try to get this particular equation from first law, as rest all parameters are neglected. So mass flow rate is given. H4 means at state 1, that is pressure 100 kilopascal and temperature minus 20 degrees Celsius. From R134A table it is 387.2, and similarly H4 is already calculated here, 241. So the amount of heat absorbed in the evaporator by R134A refrigerant is 14.54 kilowatt. The third one is a control volume for compressor. So again, this compressor means heat is rejected. So this you have to keep it in mind, minus. Okay. So when we apply first law, you decide which form. Okay. Where all kinetic and potential energies are negligible, the equation turns out to be in this particular form. So mass flow rate is given H2. H2 means enthalpy at state 2, where for R134A, P2 is 800 kilopascal and T2 is 50 degrees Celsius. For that, H2 is 435 from the table, and H1 as earlier, that is 387. Minus work for the compressor is given, it is 5 kilowatt. Since work is absorbed in the compressor, so it is minus, as finally it is 0.21 kilowatt. So that is the final solution. So try to get these answers.